Hello, Lantau, and welcome to day 3 of your science home learning, where you will be investigating what happens to the motion of objects in a collision. Before you jump into your home investigation today, you're going to be providing feedback on 2 previous Schoology discussions, day 4 and day 2. You're going to reply to 2 other students with positive and specific feedback about their model. Some tips on feedback is make sure that it is productive, meaning make sure that it is specific and actionable. Please read these 2 examples of productive examples of feedback, and also know that we're looking for something more than a non-productive example of feedback, such as, "I like your drawing, your model is very pretty." Help your classmate progress in how they express their thinking clearly and in detail. Here are some sentence starters to get you started on how to give some productive feedback to your classmates, and then also receiving feedback from your peers. Please read here what you're to do once you get the feedback from your classmates. And again, the second Schoology discussion is the day 2 discussion, where you will also be replying to 2 other students' posts. Then you're ready to jump into today's investigation. You're going to conduct an investigation at home, something similar to this one that Mr. Jackson has shown with 2 cars colliding. Please watch his video and go through the thinking routine of what I see, what I think, and what I wonder. And you're going to figure out, well, what 2 objects at home are you going to collide? Find 2 things that you can collide without causing too much of a mess. And here's an example that's very simple using coins that Mr. Jackson has shared a video of. You're going to develop a model that describes the change in motion of the objects before and after the collision. Be sure that your model has the components drawn and labeled, and that you have tried to show any forces that you have observed, which include the force of friction, gravity, or applied forces such as a push or a pull, which is why you should watch this brain pop video on Newton's laws, and also please take the quiz and insert your screenshot of your quiz results here. Once you've done that, you'll be ready to change something in your investigation. You're going to change an independent variable. An example of that could be the mass of one of the objects, such as a larger coin. And once you change the independent variable, you're going to observe what was the effect. Did that change any dependent variables in your investigation? So please explain what you think your cause and effect was here of changing your one independent variable. Then you're ready to jump back into your model and refine your model, making sure that you not only address these forces, but that you also showed any action and reaction forces, any changes in the forces you have shown in your model. So you're going to, again, refine your model from slide 11 in a before and after organization. And once you've done that, you are ready to post your model on today's Schoology discussion, which is titled Collision Investigation Model. Please describe what it is you decided to collide and what were the changes in the motion of the objects before, during, and after the collision. You're going to insert a screenshot or a video of your collision investigation, or you may insert your model that you have refined using the file option. And then you're going to explain why your object's motion changed after the collision. See if you can apply any of Newton's laws that you learned about in the Brain Pop video. And please make sure that you look at Mr. Jackson's example very carefully as you are refining your model and thinking about your post in the Schoology discussion. Notice in Mr. Jackson's model how he labels his forces with an arrow, such as the acceleration force and the applied force. And the size of the arrow tells you about the size of the force. So if it is a greater arrow, then you can be informed that that is a greater force that is being applied, as well as the arrow lets us know the direction the force is being applied, or the reaction force that happens from an action. So again, please look at Mr. Jackson's example carefully as you try to emulate this type of modeling in your own investigation. And your option for today is to take it further on this last slide. So I'm available by chat, and I look forward to hearing about the investigations that you have completed at home, as well as seeing evidence of those investigations with videos and screenshots and pictures of models on the Schoology discussion. Good luck!